Good morning, Honors Algebra 2. We're going to get started with 8.6 Day 1 notes. And we've been working with probability for the last couple of weeks. So now we've actually are going to start statistics. Okay, so we're going to talk about the normal distribution. Now the normal distribution is also called a bell curve. And it looks a little something like this. I want to choose a fun color. Let's do blue. So a normal distribution, hopefully I can draw it pretty on this laptop, is a bell curve. Okay, so that's a bell curve. And the peak of this is going to be a mean. Now, the value that we use for mean is this weird U looking thing, or you'll see an X with a bar up top. So that's the average or the mean value. Now, a standard deviation is a number used to tell how measurements for a group of data are evenly spread out from the mean or average. Average. I think I spelled that wrong. Okay, now the symbol that we use is this guy right here. Boop. Kind of looks like a sideways B or a sideways 9. Kind of looks like that. Now I'm going to abbreviate standard deviation from this point forward to SD because we all know how atrocious my spelling skills are. Okay, I don't want to burden you with having to read it. So number 1. Now, there are different types of standard deviations that can occur. If you have a small standard deviation, SD, this means most of the data points are close to the mean or average. Okay? Now, if you have a large standard deviation, you guessed it, that means the data points are spread out. Okay? So, let's move on. Let's talk about standard deviations, the different types we'll see. Okay, so this is your standard bell curve. Okay, now the entire bell curve, so the entire bell curve equals 1. Okay, and that 1 is technically 100%. That's your entire bell curve. Now, here are the different values between the mean and its standard deviation. So, going from the mean value here back a standard deviation or minus a standard deviation is 0.34. That's how many people would be in that data point. Okay, so what I want you to do is memorize the percents of a normal distribution. So important. So let's look at this first one. If you have plus or minus 1 standard deviation, so that's going to be this value right here, plus or minus 1 standard deviation. Well, 0.34 plus 0.34 gives us 0.68. And if we write 0.68 as a decimal, because they're asking, I'm sorry, not as a decimal, as a percent, this means it's 68%. That's the value you need to memorize here. Now, plus or minus 2 standard deviations. Whoa, here we go. All right, so that's going from this point right here all the way over to the second standard deviation. So that means we have to add 0.135 plus 0.34 plus 0.34 plus 0.135, and that gives us 0.95. So 0.95 written as a percent is 95%. So second standard deviation is 95% of the population. 1 standard deviation is 68% of the population, or 68% of your data points. Okay, that's what this means. Now, plus or minus 3 standard deviation. Okay, so that is going from the third standard deviation all the way over here on the left to the third standard deviation all the way over here on the right. So that means we're going to add 0.0235 plus 0.135 plus 0.34 plus 0.34 plus 0.135 plus 0.235. That gives us 0.997. And 0.997 as a percent is 99.7%. So the third standard deviation holds that 99.7% of the population, or of the data points. And then anything past that third deviation is the rest of the population, which will add up to 100%, okay, which is 0.3%. But these are the top three you need to know. The first deviation, which is 68%. Second deviation is 95%. Third deviation is 99.7%. All right. Now, here's a picture of if you have the same mean or the same average. Okay, so they all have the same average, but they have different standard deviations. What do you see happening between these three different pictures? Okay, we see that the standard deviation, or what does the standard deviation do? The standard deviation either spreads or shrinks the bell curve horizontally. So the mean will always stay where it's at, but whether or not your curve expands or not, it gets a little bit fatter or not, depends on the standard deviation. Now, for number 5, we're told the standard deviation stays the same, but the mean is different. So the mean is changing. This is 1, this is a mean of 2, this is a mean of 3. What effect does the mean have on the bell curve? Okay, the mean shifts the center of the bell curve, left or right. So standard deviation moves or spreads the graph horizontally, and then the mean moves it left or right. Okay, now let's ask some questions. So, first question. A normal distribution depends on the mean and standard deviation. Is this true or is this false? Well, we just went over this. This is absolutely true. Okay, why? The mean gives us the center. And then the standard deviation shows us the spread, right? Because it spreads the data out either largely or smallly, shrinks it or expands it. And then number 2, we have in a normal distribution, 50% of the population is within one standard deviation. Is this true or false? Well, no, this is false. This is what we did on that first page. 68% of people, or 68% of the population, is within one standard deviation. Okay? So, super important again to know what one standard deviation is, what 2 standard deviations are, and what 3 standard deviations are. All right, so letter D, we're trying to figure out the missing values in this normal distribution curve. All right, so what we need to do is, we know the total of the standard deviation by 2 is 0.95. And then my outside boys, my 0.0015, we got 2 of them. And when we add those together, we get 0.003. So what we're going to do is we're going to subtract. So these outside boys total to 0.003. So in order to figure out our boxes, we have to do 1 minus 0.95 minus 0.003, which gives us 0.047. Now that's the total that's missing, but there's 2 boxes. So what we have to do is divide that by 2, and we get 0.0235. Or if you were a cheater pumpkin eater, you looked at your notes earlier. But those are your values that you're missing. Okay, letter E. I believe this is our last example for the day. Yay! This survey shows the time spent by shoppers in a supermarket is normally distributed with a mean of 45 minutes and a standard deviation of 12. Okay, so if we're told that the mean is 45 and the standard deviation is 12, well, the mean is our middle, okay? So I'm going to zoom in here. So our mean is the middle, and that's 45 minutes. Well, when we standard deviation, we either add the standard deviation or subtract. You add it on the right, subtract it on the left. Okay, so 45 plus that 12, so I'm going to write that our standard deviation is equal to 12 on the bottom here. 45 plus 12 gives us 57. Then we have to add 12 again, so that gives us 69 for our second standard deviation. Add 12 again, that gives our third right standard deviation, which is 81. Now we're going to subtract 45 minus 12, that gives us 33 for our first standard deviation on the left. Subtract 12 again, we get 21 for our second standard deviation on the left. Subtract 12 again, we get 9 for our third standard deviation on the left. All right. Now, we are told or asked what percent of shopkeepers at the supermarket will spend 33 to 57 minutes in the supermarket. Okay, well, we know, let's look at our picture here. If I draw in the values that we have, so I'm going to draw some dashed lines here. Oops. All right, let's write in our decimals. We know the first standard deviation, we have 0.34 on both sides. Second standard deviation is 0.135 on both sides. Third deviation is 0.0235 on both sides. Now, we are asked, once again, between 35 and 57 minutes. So that's within our first standard deviation. So what's the percentage of your first standard deviation? If you memorize it, you know it's 68, or you can add 0.34 plus 0.34, which gives you 0.68, which is our 68%. Okay, so that's in our first standard deviation. Okay, next one is, what is the probability that a randomly chosen shopper will spend between 45 and 69 minutes? Okay, so 45 to 69 minutes. So we have these values here to 69. Well, we don't know what the first two standard deviations are by themselves, so we're going to add those two decimals together. That is 0.34 plus 0.135. This gives us 0.475, or as a percent, that's 47.5%. Jeez Louise, I'm sorry, guys. Okay, so standard deviation. I hope you guys enjoyed these last 3 days of notes. And I hope you guys have a wonderful day. I hope you enjoyed statistics.